Good morning, everyone. Welcome to today's webinar. My name is Susan, and on behalf of MH Service, I would like to thank you and welcome you for joining us today. At MH Service, we partner with the leading technology providers to bring innovative solutions and to share the latest advancements shaping the future of digital investigations. Today's webinar has been organized in collaboration with our good partner, Kinesense. Together, we will explore how artificial intelligence is transforming video investigations. We are pleased to have representatives from both Kinesense and Image Service joining us today. Representing Kinesense, we have Priyanit Sahai, who is in charge of pre-sales and training. Priyanit will be leading today's session and sharing his expertise on AI-powered video investigations. Representing MA Service, we are joined by our COO, Muhammad Awadala, who will deliver the closing remarks at the end of the webinar. Following the presentations, we will move into a live Q&A session, so we encourage you to submit your questions throughout the webinar, and we will answer them at the end. Thank you once again for joining us today. Without further ado, I will now like to hand over to Priyanit. Thank you so much.
Thank you, Susan. A very good morning to everyone present in this webinar. So we are going to have a session on Kinesense, and we are going to see that with Kinesense, which is AI-powered video investigation solution, how we can achieve many great things when it comes to video forensics. A brief intro about me. So as Susan mentioned, my name is Priyanit, and I look after the pre-sales and training in Kinesense. So I've been with Kinesense for the last 3+ years. And during that time, I have seen a lot of new features getting introduced inside of Kinesense based on the feedback from our end users, like all of you attending here. Because at the end of the day, it is you who are the experts who are working in the field of forensics, utilizing our tools and facing the challenges and solving the crimes, right? So yeah, this is our agenda for the day. For this webinar, I'm going to be talking a little bit about the kind of AI which is there in the market these days, which AI Kinesense uses. Then I'll talk a little bit about Kinesense. I'll talk about our motto a little bit, which is from capture to court, everything inside of one package. Then I'll talk about a little bit of analytics, which is inside of Kinesense, the different type of machine learning models we have, how it can save a lot of your time, give you results very instantly. Then we'll talk about what are the type of data on which we have trained the models of Kinesense. And lastly, we'll see how Kinesense can work as an advantage for your lab, for the manpower who is working on the field, how Kinesense can become an advantage. And then we'll move to the actual tool demo. So yes, don't worry, the presentation is not going to take a lot of time. I'll be giving more time to the actual demo of the tool, right? So yeah, talking about the AI, the biggest hype of the current days, there are basically three type of AIs, two types I have mentioned here. The first is generative AI, and the second is classifiers based AI. And the third one, which is more prevalent these days, is agentic AI. But I'll talk about these two things, generative and classifier based AI. So generative AI is what you see or what you have been seeing in ChatGPT, Claude, or Gemini, or any other AI that you use on a daily basis, right? It has been trained on the data which is available publicly, whether from internet, from various books have been scanned for, absorbing the data and the training the models based on those books. Some videos have been shown, a lot of movies have been copied, and things like that. So that model is trained on each and every bit of data that is available publicly. And so therefore, when you ask a question to a generative AI, it will take all those points and generate an answer for you and present to you that answer, right? The second type of AI is classifiers based AI, which is what Kinesense uses. So what is the difference? So classifiers based AI is trained only on specific objects. The thing that is with classifiers is all the classifiers have a particular task to do. So if there is a classifier which has to identify a vehicle, it has been trained on millions and millions of images of vehicles, images and videos both of vehicles. So it will identify a vehicle for you if in an investigation you need to find a vehicle or a human being or different type of objects. So that is where the classifiers based AI will come handy for you, right? We'll see some examples also. Uh, like let's look at this example. So this is actually a 5-minute video clip taken from a CCTV which is facing towards a parking lot, right? So what's happening here? Actually, in the video, what's happening here is this white hoodie man, whom you can see here. He is actually roaming in the video, and he's going over to the cars and looking what's inside. He's trying to steal something out of this video, these parked cars. So what we did, we gave this video onto ChatGPT, and we asked ChatGPT, give me a description of this video. So you can read here. The chat gpt came back to us with this description, wherein it says that the video shows a red car parked in a parking lot with other cars. The car remains stationary, etc., etc., and there are no other significant events, right? So what happened here? The generative AI totally missed the point of investigation. It did not see this video from that lens where this person might have been trying to commit a crime. So that is what distinguishes it from the classifiers based AI, that generative AI is not really, beneficial for investigators while they are doing any investigations. So, what do forensic investigators need in AI actually? So, that are these 5 points. The models, it should be trained on real police data, the police database, the case studies, the experiences. The model should be trained on those things, right? The outcome of the solution should be proven in court, right? It should be provable in court. Repeatability, the result a tool is generating today, it should be generating the same result after 6 months, 6 years, 60 years, whatever be the time, it should always generate the same result. Then comes the reliability. It should be reliable. So if it is not seeing anything which is worth investigative points, it should fall gracefully and tell you that, sorry, I am unable to solve this thing, or I am unable to find anything worth importance to you. And lastly, the audit trail. It should keep a record of each and everything. Even if I am watching a video frame by frame, it should record everything to create this a chain of custody or audit trail inside of the solution. So Kinesense solves all these problems, as we'll see in the next few slides. So a brief introduction about Kinesense. This is an AI video solution, and our motto is everything from capture to court. Right from the moment you have a video, either from CCTV, from body-worn camera, from drone, from mobile, from computers, anywhere, you take it in Kinesense. That is the first step. After that, Kinesense will take care of everything until the time you produce it inside of a court. So I'll not be taking a lot of time here. These are some of our customers. There are a lot of more. We have been in this field since 2009. We have been constantly listening and upgrading ourselves based on the feedback we receive from our customers, based on their requirements. We are a very small team, but very efficient team based out of Ireland, Dublin, Ireland. So we'll be talking first about the analytical edge of Kinesense. I'll right away jump to the slide. This is a very small video. Um, I'll be showing more of it in the actual demo. So I'll just play it a little bit. And you'll see that there's an object which is moving. This is a very poor quality of video, but you can see that when it is moving, we are able to identify the points around that object, and everything is getting shown here on the timeline on the bottom. So I'll just pause this. These orange stripes at the bottom, these denote the movement of any object inside of this video. So whenever this object is moving, you will have a orange stripe like this. And where there is no movement at all, you don't have anything in the timeline. So Kinesense, the models running behind, are able to identify any moving pixel in a video and show you just in the timeline so that you can quickly move over to these different points and see what all things are moving in the video. So this is one of those things that's we call this object identification or event detection. So we'll see more about it in the actual demo. Now let's look at the challenges which the investigators are facing today. Um, so most of us, it is like, you know, there's a lot of video data nowadays, like a lot different sources, more and more video data every day. So the workload is getting more impossible every day because the manpower is very limited. So we can't expect the whole police station, for example, to just sit there and watch the video, finding that one important event in that 200 or 300 hours of video footage, right? And finding event is one thing. Correlating everything is the next big step. Next big step. You find a face that you are looking for. You find a vehicle, whether it is a car, bus, truck, whatever, and then you find the location, the actual location where an event has happened. Now, after you have all these pieces, you have to glue them together and make a case out of these things. Basically, you have to convert the data into intelligence, right? So this is where Kinesense will come handy because we'll see in the demo, we have a tab called grid wherein we can see all these things together and we can relate how a person was seen moving from one video to another or from one camera to another, who he met and all these kind of things, right? So Kinesense is mostly for post-event investigation after something has happened. But you'll be glad to know that recently we have released a new product called Kinesense Recon, or just Recon, wherein we now support live video investigation as well. So currently we are only supporting the RTSP stream, real-time streaming protocol stream. So if your camera supports or outputs with a RTSP stream, we can directly take it into Kinesense. So what these are some features that we have. Bulk object detection. We can search by class or color. What I mean by that, if I want to search only for motorcycles, two-wheelers, or let's say cars, only red color car, things like that, we can do all these things inside of Kinesense. Then we have recently we also released the OCR feature inside of Kinesense. So until a few months back, we were only able to identify the license plates. We were not able to extract the numbers. So now we can also extract the numbers, and so what that will enable you, that will enable you to do manual searches of numbers as well, license plates I'm talking about. So we'll see all these examples. Then we have face recognition as well, but face recognition is an add-on module. It needs to be purchased separately. It does not come with Kinesense LE by default. Everything else you see here comes with the Kinesense LE package. So these are some case scenarios or case studies. I'm not going to take a lot of time here because you will understand it more in the examples that I'll be showing. So this is what I was talking about. We have real-time alerts. If any object is found, you will have a real-time alert. It's not going to take 5 or 10 seconds after that thing has been found, right? We can find things only in a particular zone. We have configurable triggers. As soon as you find a red car, your trigger will run automatically. That kind of things, right? So again, not taking a lot of time. Now let's talk about some of the AI modules inside of Kinesense. So face recognition, as I mentioned. So there are two type of face recognition. One is face detection, only detecting the faces, right? And extracting all the faces from video. The second thing is actually matching this face with a suspect's face. So these are two different things. Face detection is it's included freely inside of the standard version in Kinesense Recon. But when you need the actual face recognition or face matching, that is an add-on module. And you can see that with our recent version 6.1, it's already 50% faster than the previous generation. So it's very quick. The result is very quick. I'll show you some examples of this as well. This is one such example. So this is the example of live RTSP camera, the newest product release of Kinesense called Kinesense Recon. So I'll skip this setup part. So the camera is set up. Now I am setting a trigger. You can see I am telling Kinesense that when a person named Bob Builder is found, you just give me a trigger here, and all the triggers will appear here. You can see currently it says unknown, unknown, unknown. But let's see when this is set up, and now trigger is saved. Now this person, as soon as he came in, you see his face is getting recognized. Bob Builder, Bob Builder, right? So now let's look at the science behind this. So this is the person we have already registered in our database. We have named him Bob Builder. So this is just a representational image. So what Kinesense does is it takes all these points and does calculations based on this. And you can see here, even when this person is wearing mask or when he is wearing a helmet in which much of his face is, hidden, then also we are getting a very good result with a very high confidence. So this confidence ranges from 0 to 1. So you can read it as 94% or 80% or things like that. So the worst result is this one with only 43% confidence. And you can see that the image is very much blurry, right? But we have some fantastic result when it comes to face recognition. This is about the license plate. Not taking much time here. We support the license plates from more than 50 countries. If you have at least three numbers or three characters of the license plate, you can do a manual search. It will search from all the vehicles it has identified in a database. We do now OCR extraction also. You can search based on that. So all these things, all these features are there in Kinesense, and we are using AI and machine learning models have been trained based on various data, which we will be talking about shortly. Now let's move to a very interesting algorithm or AI model that Kinesense has. We call this attribute recognition. So what happens many times you might have also gotten a case like this in which you have to find the suspect, you only have this information that the suspect was wearing a red color shirt and he was carrying a bag on his back, right? So even with this information, you can do all these kind of searches inside of Kinesense, and this is what we call as attribute recognition. So Kinesense not only sees a human being, it sees so many things like the gender of that person, the hairstyle, headwear, if he or she is wearing a cap, if he or she is carrying a bag, the type of sleeve length, whether it is full sleeve, half sleeve. So you can see that there are so many different characteristics or attributes of a human being that Kinesense sees, right? For the vehicles, we see different things also. So they are like the type of vehicle, whether it is a car, van, bus, truck, these kind of things, or different colors of the car. So whether that car is red color car or that bus is a blue color bus, all these things Kinesense sees, and it comes really handy in Kinesense. How does it come handy? Let's look at an example. So we knew that our suspect was a red color car. All we had to do was right click on this suspect vehicle and click on re-identify. Then automatically our screen got filtered and we were seeing only red color car, you see. So it is possible that not all of these red color cars are your suspect vehicles, but it saves a lot of time, right? You are only seeing red color car. You can quickly, go across all these results. You can see here now out of 627 results which were earlier, which were having all different kind of vehicles or different colors of cars. Now you are only left with 18 cars. So you can understand how much time is saved now. You just have to look at 18 results instead of 627 to find just one car, which is this car, right? So this is where these AI tools come really handy. Now let's look at some of the data on which Kinesense have been trained on. So you can see for identifying a person, we have trained the models on more than 181,000 images or videos, right? For detecting license plates, it's more than 103,000 images. For face detection, more than 60,000 images. And you can read all these numbers. These all look really good, right? But you might think any software can train their models on, more than these numbers that you are seeing here. Yes, that is correct. But what makes Kinesense difference? is that the data on which we have trained Kinesense is all real world police case data and the footage which comes out of CCTV or different cameras. So let's look at these. So these are how our data set is curated. We have a lot of different footages from day, night, different scenarios, different weather, different sources like whether it is CCTV, dash cam, drone footage, body worn camera. Um, so basically, it is representative of what our users would encounter in real world scenarios. You can see all these footages are from CCTV cameras. It's not that we have taken a video from YouTube and trained our model on that. So one more example here, you see all these images on which we have trained human beings, different ethnicities. It's not that we have footage only from China or US. We have taken the footage from all over the world, and you can see that it is able to um, you will see later on that it is able to identify these things in a very much superior way when compared to other tools. So yeah, just 2 more minutes for the presentation, then I'll be moving on to the actual demo. I hope no one is getting bored because giving a base was necessary before showing you the tool. So now let's talk about Kinesense advantage. So we support a lot of cameras. Apart from this, we also give you an option of downloading almost 900 CCTV players so that you are able to import each and every format that is out there in the world. You know that one of the challenges of CCTVs is that a lot of video formats are proprietary as well. So in that case, you will not be able to play everything. So that is why we give you an option of almost 900 external players. Apart from the codecs that Kinesense supports, you also have 900 external players. As I mentioned, we have recently launched Recon, which supports RTSP, real-time streaming protocol. So you can connect to live cameras as well and set triggers and get, instant notification and all that kind of thing. So the kind of AI Kinesense uses is powered or accelerated by the GPU uses as well. You get faster results now because of this GPU thing, right? So we have disclosure like whatever you are doing inside of Kinesense, if you enhanced an image or even if you viewed a video for like say 5 seconds, everything gets recorded and we can produce a PDF for each of these actions so that you can present it in the court of law just to make sure that the complete chain of custody was maintained. Our solution is fully on premise, although we are coming with a web version as well, but it will be totally your choice. You want to go with total air gap solution or you are comfortable with using the web version as well. So we are totally complied with ISO 17025. Our reports are totally complied with ISO 17025. We have access-based authentication as well. We can give the solution based on different roles. Like if there is an inspector, police inspector role, they might not be able to access certain things. And if there is a senior to them, they can access everything. So access-based authentication, basically. So yeah, last slide, everything that I've talked about, built for investigators, built from the feedback of investigators. We improve daily. What are the challenges they face and things like that. Fully on premise. No data of your leaves your premise, right? Everything happens on your local computer itself. Real-time results. Use of GPU makes it faster. So Kinesense is modular. You need not purchase everything at once. You can start with just basic Kinesense, and then as per your requirement, you can add more modules to it, right? So we have evidence standards. As I mentioned, we have the reports generated from Kinesense is ISO 17025 compliant, proven globally. Our solutions are used everywhere. We have a lot of partners. They keep on selling our solutions. So yeah, that is not a challenge. Optimized for CCTV formats. When this solution started, it was just CCTV producing video footages, right? But as the time progressed, we now have a lot of different sources, not only CCTV, but yes, we have not left CCTV. We have added more support, but CCTV remains our primary focus, right? And then usability and training. You will see that just in a few seconds, you will see how easy it is to use Kinesense. And if you find it little bit, uh, I mean, not easy, for that we have really great training options as well, right? So that brings me to end of my presentation. I hope you paid a little bit of attention, because now I'll be showing you the actual tool, and so you will understand why I gave this presentation that I did, right? So this is the interface of Kinesense. As you can see that I am running version 6.1 from here. This is the latest version of Kinesense, and we have several tabs here on the top. You can easily understand that any video you can add in Kinesense from this tab called Add Remove, right? You have different options here, adding multiple videos or working with a single video as well. Recon again is a separate module, but since this is my demo machine, so I have everything at once. If anyone just has Kinesense LE, they will not see the Recon tab. They will just see Add Remove and then Review and the rest of the tabs. So Add Remove is the place where we add the videos. Review is where we review the video, where we use the AI to, find the things that we want to find. Then we have report. In the report, we just don't generate the report. We do a lot of things. We do enhancements. We do annotation. We have our disclosure here, wherein every step is recorded. And then ultimately, you have two options of either exporting a video report. For that, we have different options. Like if you want to export one video, you want to export all the clips into separate videos. You can also export in PowerPoint, in PDF format, or you can directly burn it into a CD drive as well. For image, we have three type of reports: PDF, Word, and uh, PDF, Word, and PowerPoint, right? Then we have tags. Obviously, this is not a demo of the tool, but I'm just giving you a brief about what all the features are there. And in the subsequent webinars that we'll be having, we'll be deep diving more into each and every aspect of Kinesense. So tags is something you can see here. I have several tabs here for this database that I have opened here. So let's see, if I am working in a department today and I get transferred after a week and someone else comes in my place, so it will be really easy for them, just to go to this tag section and see what all things I have found. They can, see all the comments that I've added, why I found it was important, or whether it was critical or uninteresting, and things like that. Everything is getting recorded inside of your database. That is why we say Kinesense from capture to quote. You don't need to leave the tool. Everything can be done inside of this. And again, our most important place we call the grid tab. Here we see the magic of AI happening. You see everything is getting identified here. Um, Even if a person's hands or legs are visible, it is identified as a person, for example. Yes, I'm not saying it's perfect. You might have a few false positives, but yes, that is accepted because we give you the option to filter them out as well. You see, there's a person here, it is getting identified as person. And we'll see more examples. We have a lot of things here to show. We have face recognition also. Like if you have your database, you can easily find these persons from that database. Then we have license plate recognition. This is something I mentioned earlier. So if you see, uh, now we also not only read the license plate, FL57BYS, we can also do a manual search if we know at least 3 characters of a license plate, right? Then we have some image authentication and some feature of maps as well, on which we can represent anything that has happened in a video on a map as well, right? So yeah, now let me actually show you some videos on which I'll apply some filters, right? Let's take the example of this. So this is a footage of a parking lot, right? I have, so there are several algorithms inside of Kinesense. Let me quickly show you that. And so yes, we have these algorithms. One is event detection. Remember the example I showed you in the presentation? It will detect any movement, right? And you can filter based on color, direction, all these things. But if there's a video in which there are There is a human being, there's a car, there's a bus, there's a bicycle, there's a motorcycle, all these different things. If you want to only see the human beings, for that event detection will not work. For that, you have to go to event detection and classification, because you only want to see the humans. You want to exclude all the other things. So that is why classification is necessary, right? Then we have license plate recognition. The name only says what it will do, right? It will extract the license plates and show to you. Then we have attribute recognition. This is what I showed you, that example, that Kinesense sees the human being and also all the features they have, like which color cloth they are wearing, what is the hair length, and all these kind of things. Then we have object detection. This is similar to event detection and classification. It's just that this is a newer model, so it gives faster results, better results. But we have kept both of these because some people still prefer this and some are starting to like object detection. Then we have face recognition. I'll show you a very good example of this face recognition as well in one of my databases. And then if you don't want to do anything, you just want to import a video, save times, for that we have none algorithm also. So in this video, I have processed this video using event detection and classification. You can see here the algorithm. I have used only one algorithm here. Algorithm is the AI model, right? If you want, you can have multiple, like if you want to find event detection, you also want to do attribute recognition, you also want to do face recognition. So you can do multiple algorithms in one video. So, okay, now let me explain you the scenario. So this is a video of only 5 minutes, but let's say this video was of 5 hours or 2 hours or 1 hours. And all we wanted to do was to find if any car has come in this particular parking place or not, this one. So for that, what we'll do, we'll start playing the video. For example, let's start from here. We'll start playing the video and play it frame by frame, or maybe play it at 2x or 3x speed and try to find whether a car has come here or not. But that's not how we do the investigation part. How we do investigation in Kinesense? We go to this icon that says filter. I already have a lot of filter created here. So let me just show you how this works. And what I'll do, I will go to enter filter mode. I will create a filter and let's see what happens. Enter filter mode. I'll select, let me do one thing. Just pay attention to this timeline. You see there are so many orange stripes here, right? And all these stripes denote any movement in the video. You see this car is moving here in the back and we have this dashed line area around this car. It is because the model is identifying this car as a moving object. And all this moving object will be represented by one orange stripe, right? So let's see. As soon as I select this filter that I have created, you will see that it has changed totally. The timeline is now changed, right? So let me first explain what has happened. So in this, what I have done, I have told Kinesense, then look for an object in all the directions of movement. I am not specifying any one direction of movement. Then I have told Kinesense that only look for a car. You see, there are different options. There is a truck, bus, bicycle, human being, motorcycle, van, a car, or miscellaneous. But I have just told Kinesense, show me only the cars. And lastly, there are the option of selecting color of the object as well. But I have selected all the colors because I don't know which color car will be coming here. My only requirement is I want to only see the cars coming in this area. And as soon as I select this filter, you saw that the timeline changed completely. So now let's look at what's happening. And last, most important thing, I have told Kinesense that only show me the results in which a car is coming and touching this area, only this area. If a car is moving here or there, I don't mind, right? That's not my requirement. So let's see the results. So you have two results here. One is this. Why do we have this result? Because this car is, as you can see, it's coming and touching this region that I have defined, right? Then I don't have any result in this area, even though we see a car is moving here, but we don't have any result here. And there are a few cars moving in the back as well, as you can see, right? But we don't have any result because our primary car, which we want in this area, is not moving. Then we have another result here, and that is because you see, again, this car is moving and leaving this area that we have defined. So this is one example. Now let's look at some other example. In the same video, let's look at some other example. Let's look at this example now. So what's happening here? Again, I am looking in all the direction of movements. Now, instead of car, I am only looking for a human being. As you can see, human being is highlighted here. And also all colors are selected. Now, I have moved the zone of interest at a different location. And now I only want to see if any person has come inside of this area or not. So when I selected, you can see the timeline is now totally changed and I just have one result. Why do I have this? Let's check it. It's because this person is coming out of the car and touching or crossing this area that I have defined. Right. So this is one such video that I wanted to show. Let's look at this video. Even for a very poor quality video footage like this is a camera from a border. You can see that it has detected so many events, and the algorithm the model I have used is again event detection and classification, but it will not be able to classify it as human. Why? You will just see, because you see, this is how we are seeing the movements. No model can tell this that these are human beings or some other object. It's just detecting the movements. You can see that even for very poor quality, we are able to get a very good result, identifying all the movements across the border. So this is one other video just that I wanted to show. Now let me quickly switch to some other database and I'll be showing you some other things. Yeah. Now let's look at this other database that I have. I'll be showing you the license plate recognition now. So you see now I have this. So I have two algorithms in this video. One of them is OCR, and that is what I'm going to be talking about. So this is the kind of footage that we have, right? And let's look at the results. So where do we get the results of license plate recognition? We get all those results in the grid tab. You go here, you will have several options. You go to the license plate recognition. And here, since we have already filtered this, so you are only seeing the results in which the license plates have been identified. So let's say that you only remains 3 characters, something like JVL, and you don't recall all the numbers. So you can do a search and you can go to contains, and now only the result which will have JVL inside of it together, like either at the end or in the middle or at the starting. If only it is together, you will have your result like this. Excuse me. So this makes the license plate searching very easy. Uh, if you remember, partial license plates also doesn't matter. It will be giving you the results, right? So this is one thing that I wanted to show. And how do you, most importantly, use these AI modules? So let's talk a little bit about that as well. You come to the add remove tab, you click on add video. I'm not going to show the complete video import process, but just for example, you select your video, you can drag and drop as well. It will show you all the important features of that video, all the metadata. If you want to go more in more depth, you can do that as well. Then you click on next. I'm just going to show you how easy it is to import a video and select your AI model or algorithm as well. If you want to wait here for the preview of the videos, you can wait, or else you can click on next. Excuse me. So yeah, again, that screen comes. This is the most important screen, your import wizard, the which algorithm uh, screen. You have to select one of these algorithms as your first step. So if you want to find the license plate, or if you want to extract all the license plates from a traffic footage, obviously it will not make a sense to go with face recognition or attribute recognition or event detection. Attribute recognition will even make sense because it will identify the type and color of vehicles, all that thing. But for license plate, you should go with the license plate recognition. And we have made it really easy. Like if you are getting confused at all this, we have a help section here as well. You can quickly open this and go through all the material here and see everything, like what are the things which will be identified in a vehicle and different kind of things, right? So all that will be happening here instantly. All the processing will happen only once when you are importing the video. So even if it is a face recognition, all the faces will be recognized when you are importing the video, then only. After that, it's really easy for you to do facial search. It's not going to take a lot of time there, right? So I have one more video here of the this thing, event detection. Let me quickly show you that as well. So you see, this is a footage inside of a room, from inside of a room, and we see we don't have any movement here in this section. We don't have any movement in this section, and then we don't have any movement in this section. But we have some results here, and this is where the movement is happening, you see. And this is going to save a lot of time in your investigation because you'll not have to wait for the movement for you to find when the movement is happening, right? So the main objective of this object detection or event detection and classification is to save time and show you the results in just a few clicks after when you apply the filter. So we have applied a filter here in this region, and anything which is moving past this area, is getting recorded here as a event or a movement, right? Now let's look at something called attribute recognition. Where will we find the attribute recognition? Again, in the grid tab. We go to the grid tab, and here we'll have this thing called attribute recognition. We click on that. And now you will have everything that has been identified in this database. The database which I'm currently on is this Op Tempest H264. And you can see that it has identified a lot of persons. So, we can filter the categories based on here. So if I select persons, I will only have the result of persons. If I select car, most of the results will be of car. As I mentioned that there will be some few false positives, which you can easily delete like this. So this is not going to delete this image from your database. It's just going to delete from this window so that you have more relevant results. So that is for the cars. If you want to see the buses, I'm not sure. Yeah, you can see we have a lot of buses also here. Not sure about bicycle. Yeah, so you have results for bicycle as well. So you see, AI is in play here. It has already identified these objects when you imported the video, and you can only understand if you're solving a case in which you have multiple hours of video and you only want to find a person, or let's say a car. So you can easily do that. So let's go with person, or let's go with all here. Data available. Now, let's say this is our suspect. So let's see what Kinesense sees in this person. On the right hand side in the details, you can see that Kinesense is able to see all these things. The age group is adult, the gender is female. This might be wrong a lot of times. So for that, you might see male/female. Here, the upper body color is yellow. You can see the lower body color is black, right? Hair length is long. That's debatable. It's long, medium, or short. I don't know. The lower body color length is long, and the sleeve length is long sleeve, right? So these are the attributes that Kinesense is able to see in this one particular image. Now let's say that this is our suspect, and she's carrying a bag also here. It's not visible to the model here because of the side angle. So let's see. We want to find this person from different cameras or wherever he or she is appearing. What I'll do is right click on this person and click on the first option, that is re-identify. So this is what I talked in my slide, correlating everything. This is where this re-identify thing comes really handy. So you see I have, out of 748 results, I am left with only 41. And what this 41 means, it means that this suspect that I had earlier, these people have similar attributes to this person. So this is the difference between face recognition and attribute recognition. It's possible that there must be some other person who is wearing a black uh, lower body cloth and a yellow upper body cloth. That will also appear here. But again, this is going to save a lot of your time. You now just have to manually look at 41 images. So you look at these and you see that, yes, this person is appearing in a lot of different places. And you have some results like this. So what you will do, you will just click here, do a right click here and click on show in review, this button here. So let me show what this will do. When you will click here, what will happen will automatically move to the review tab where we watch the videos and automatically move to this particular frame of the video. So you can see what is happening exactly at this point of time. So let's see. Oh, I see that this person is meeting someone else and exchanging something. So this is a dummy video which we recorded, but yes, this is good enough to make you understand the point of this. And now what has happened? That bag that yellow person was carrying is now being carried by someone else. So we got one more lead here, that this person wearing black and that person wearing yellow are somehow interconnected or related, right? So this is how you correlate things. This is how AI inside of Kinesense enables you to correlate things when you are investigating video footages from multiple sources, from different cameras, from different areas, right? So this is one of those examples I wanted to show for attribute recognition. It is very handy. Now let's look at something else. So we don't have a lot of great car footages here, but let's see if we only want to find buses. Let's see whether it no, it's identifying it as a car because of this thing. So no good results here. But yes, we have one more. This person here. Let's see whether we are able to re-identify. So yes, now let's see that this guy is appearing here in a different video, and then at a later stage, he is seen carrying a bag. So somehow we are able to, I mean, track the movement of both these people. This black hooded guy and that yellow sweater wearing lady as well. So using attribute recognition gives you a lot of options, a lot of filters are there. This is all dependent on you, your investigative mindset, how you utilize this thing. And these are the filters on the top that Kinesense is applying based on the AI module it has been trained on. So this was attribute recognition for you. This is again very much helpful. Just give me a second. I'll be switching my database to face recognition. That is the last part of our webinar today. Then we'll be opening the session to flow to the questions. Okay, so this is opening. Let me show you one face recognition example in this database also. So we have a footage here in which I'm trying to open a different database also. That's why it's taking a little bit of time. Please bear with me. Yeah. So we have a different footage here in which some people are coming down a staircase, and we already have these people registered in our database. So you can see that as well. You'll have to ignore some results. So we have one guy here. We have uh, one lady here and one more lady here. So all these people will be appearing in that video, and you will see that Kinesense is identifying these people in real time, right? So this guy is getting identified here. Then we'll move to the next event. So you see this lady also got identified for a second there. Again, a third person is getting identified. So this is just one scenario in which the camera is static and lot of different people are coming down the stairs and Kinesense is identifying these people. Now I'll show you a more complicated scenario. This one in which I have a suspect enrolled in my database, right? This is my suspect. I have already registered him in my database, and I have several videos here. So I have a footage from inside of a bus. I have a footage of a escalator where a lot of you can see that it's very crowded. A lot of people are coming down the escalator. Then I have a footage in which a lot of people are moving inside of a metro station. We'll see a footage of a vehicle parking as well. Two footages here. So yes, this is the scenario here. I have collected footages from all the nearby areas where an incident has happened. Now, I have my suspect also registered inside of Kinesense. After how did I import all this? So I imported all this by selecting which algorithm? For sure, face recognition, because I want to find the exact match. Now, how do I find this person, this Anupam Kumar, whom I have registered? How do I find him in all those videos? Can you take a guess? Should I watch all these videos at 2x, 3x and try to find and note down every time? No, that is not what should happen in a real scenario. This is where the power of AI comes handy. And you see how easy it is. I'll just go to my grid tab. I'll go to my registered face and I'll just do a double tap on my mouse like this. And you will see all the filtered result here. As I mentioned earlier, all these calculations happen only when the video is getting imported. So it's not that every time you search for a face, it's not a lengthy process. It will give you results in seconds. So now look at the results. Uh, so it's the same video till here, right? It's just the different timings and different face angles. But yes, you can see here, it's a different video, suspect vehicle parking one. This is a different one, suspect road one. And our suspect is appearing in all these different places at different angles. And you can see the worst result that I have is of 21%. And the video is from metro entrance. I have results from vehicle parking, escalator. So let's look at this one. This is interesting. How do I manually verify this? I just do a right click and click on show in review. It will automatically move to that part of the video where our suspect is appearing. You see here, this is our suspect. If I move a little bit backwards, I can see that my suspect starts appearing from this moment, and Kinesense tracks this person. You see his face with an 85% confidence. It identifies our suspect here, right? So this is one example. Let's look at this. This is the worst result that we have with 21% or 0.21. So you see here the confidence, right? This is this can be set to 0 as well. But when I set it to 0, see what happens. I have a lot of false positives. So this is just 9.9%. This is 9.5%. And we have a result for uh, 0.051 also. So just to make sure that these results do not appear, I can move the slider as much as I want, but I'll move it only to a point where only my suspect is visible. So let's look at the worst possible result. Click on show in review. And yes, here I can manually verify that my suspect is visible to me, right? So yes, not taking a lot of time here because I think we are almost at the end of the webinar time. So just to repeat what all I showed you, the type of AI Kinesense uses is classifier based AI. Our models are trained only on doing these, identifying these particular things, whether it is motion, faces, attributes, license plates. So all these investigative purposes are getting fulfilled by the type of AI we use inside of Kinesense, right? So yeah, that's all I wanted to cover for today. Um,
Thank,
yes, thank you.
thank you, Brian. Thank you so much for the useful information. We have only one question here. Let me read it. Is there any percentages of accuracy when sending a queries to the EI about specific object, or it's 100% guaranteed to be accurate?
No. So yes, that is the shortcoming of AI. Nothing can be 100% sure. That is why we give the confidentiality number also with the results. Like if Kinesense is 90% sure, it will show you as 90% sure only. It will not try to please you that, yes, this is the accurate answer, always go for this. Will always give you the result along with the confidence as well, whether Kinesense is 20% sure that this is the same person or same object, or whether it is 90% sure or 99% sure. Yes.
Thank you. I hope that's a good answer to that question. So before we wrap up today's webinar, I would like to extend my sincere thank you to everyone who joined today. And we hope you found the today's session informative and valuable. Thank you again to Kinesense team, especially Briannet. And thank you to Suzanne from our team for arranging this useful webinar. I need just to share last information to show everyone our homepage. So please, we have YouTube channel where we post our videos, our news, our products. It's MH, it's MH House of Forensics. Please feel free to visit and subscribe for our YouTube channel. We have our newsletter. We send every month. By end of the month newsletter. So here you can subscribe for our newsletter to receive the informations related to events, related to new products, related to digital forensic investigation. And you can see also here on our homepage our products, our next exhibitions, the next classes, upcoming classes. So we are happy to assist you. We are happy as well to give you a demo license to test Kinesense and to evaluate the software. So thank you again and wish you a good day. We will share the recording afterwards to the registered emails. Have a good
Thank you
day.
everyone for attending. Thank you, Team MH. Have a good day,
Thank
everyone.
you so much. Thank you so much, Briannet. Have a good day.
Thank you. Bye-bye.
Bye-bye.